All right, in problem 4 here, we want to solve the quadratic equation by showing and explaining the decision-making process to find a solution. First, check to see if it is factorable, and so we want to see if it's factorable. So before we do that, we've got to add 5 to both sides, and so then we end up with t squared plus 6t minus 20 equals 0. So then we want to check to see factoring. So t squared minus 20. So that's negative 20t squared. So we want to look at the factors of 20 that add up to 6t. So 1 times 20, 2 times 10, 4 times 5, oops, not 4 times 6, 4 times 5. And so this is a negative, so we have a plus and a negative. So because this is a minus, we're subtracting 1 and 20 and 2 and 10 and 4 and 5. But the problem is we get 1, 8, and we get 19, and none of these will be 6. So because of that, it's not factorable. All right, so factoring's not going to work. If not, can you solve using perfect squares method? Well, no, because the perfect, whoopsie, because the perfect squares method, no, oh shoot, let me try this again. So, no, the quadratic is not a perfect square. Quadratic, no, the quadratic is not a perfect square. All right, so we know it's not a perfect square, so I've done this, I've done this. Can you solve by completing the square? So, if I've got t squared plus 6t minus 20 equals 0. So using completing the square, I basically want to complete the square. I've got t squared, 3t, and 3t. So then I know this is t plus 3, and this is t plus 3, and so this has to be 9 here. So in order to do that, I have to add 9 to both sides. So we can look at it as t squared plus 6t plus 9, and I'm going to move the 20 over to the other side and then add 9. So there's several different ways, but basically to complete the square on this, I had to add 9 to both sides. So I just moved the 20 and then I added 9, and so this ends up being t plus 3 squared equals 29. And so then I take the square root of both sides, and t plus 3, the absolute value of t plus 3 equals the square root of 29. And so then this means t plus 3 equals square root 29, or t plus 3 equals negative root 29. So then you get t equals negative 3 plus root 29, or t plus 3, oops, I lied. That would be t equals negative 3 minus root 29. And that's your answer. And so we don't need the quadratic formula.